Okay, we are going to look at what's called arithmetic sequences. These are sequences whose domains are consecutive integers. And I just have a couple of sequences here, okay? These actually are not arithmetic sequences. I'm going to show you how to figure it out. But the domain, so this would be my first term, right? So these are my x values. And these are my y values, okay? And we've already talked about, so this would be my second one, my third one, and my fourth one. And so on here. This is my x value, 1, 2, 3, 4. These are my y values, okay? So what we're looking for is a common difference. And it's very similar to the slope. Okay, and to find the common difference, it's just fairly simple. What we're going to do is you just take the second term and subtract it from the first term. And you're going to get, in this case, 4. And a lot of times you can see the pattern going on. So 9 plus 4 is 13. So here, the common difference is going up by plus 4. Now on this one is a little different. So we've got negative 32, right? Minus negative 26, okay? That's negative 6. Then the second one, negative 38 minus negative 32. Okay, that again is 6. So we think we have a common difference. However, the last one kind of trips us up a little, because look at this one. Negative 45 minus negative 38 gives us negative 7. So in this case, we do not have arithmetic sequences, okay? There's two rules we're going to go over. We have one rule which is called the arithmetic or the explicit rule. Now, there's one formula here. I actually like to use another formula because it's very similar to our slope-intercept formula. And D is going to be the difference. N is going to be the term number we're going to try to find. And then C is what we call the zero term. All right, and I'm going to write that down here for us. Okay. Some people like to use this formula also. But when you distribute the formula, you're going to get this anyway. And again, I like it because it reminds me of the slope-intercept formula. Now, this recursive formula is just a formula that tells you what the number is going to be. And it's not really a useful formula. I don't really find a value to it. But we have to learn how to write the equation in that formula. So what we're going to do here is we're just going to determine if the sequence is arithmetic or not. Okay, so if you look at the first one, it's going down, as you can tell. Is it going down by a, I'm sorry, it's going up, not down. Come on, 43, it's going up. And actually, the difference, it's going up by 11, okay? So the next one we have 14, 15, so we have 4 here. And then the next one, we have 22 minus 18 is 4. Then we have 27 minus 22 is 5. All right. So again, you got to be careful. You got to check all of them. This is not an arithmetic sequence because this does not all go by the same number. All right. And then the other one is, let's see, we've got 12.3 minus 14.6, so we have going down by 2.3. Let's see if that continues, right? So we're going to do 10 minus 12.3. And we always want to check the last one, right? 7.7 minus 10. So this one is the difference, again, is negative 2.3. And again, what I did is I subtracted the second one from the first one, okay? And they all have the same pattern. And then you'll notice the second one, you can kind of tell it's going positive, negative, positive, negative. I can tell right away there's absolutely no pattern on that, so that is not, or no, we don't have an arithmetic sequence there, okay? We're actually going to go over what's called a geometric sequence later on in the year on this unit, okay? So then you'll see some of these other types of sequences. So we're just going to talk about arithmetic ones now. All right, now let's go ahead and we are going to write the different formulas, okay? We're going to write the explicit formula. Again, I'm going to just write it down here. So it's AN equals D, the difference, the number, right, plus C. Now the recursive formula, and I'm going to show you this. Again, I don't find any value with the recursive formula, but I do find the explicit formula very helpful, especially when you want to find a term way down the line, okay? So what we're going to do here, and you have to also list A1, all right? So the first thing we're going to do is find the common difference, right? So let's start with the explicit formula. So we notice that it is going up by what, guys? It's going up by positive 8, okay? So my difference is positive 8. Now, C is what I call the zero term, okay? So if you look at this term and we're going up by 8, and this is my first term, right? What would the term before this be? And that's going to give me my C value, okay? And if you think about it, instead of adding 8, I would subtract 8. So my zero term would be negative 18. Okay, so the formula for my explicit is going to be the difference, which is 8. And my computer's going a little haywire. It does this sometimes. Okay, minus the zero term. That's the term before the first term would be 18. It's sort of like your y-intercept, okay? So this is my explicit form. Now the recursive form is really simple. Okay, A of n, again, means any number. A of n equals, now this is always going to be part of our recursive formula. So it's going to be A n minus 1. And all we're going to have to do is put the difference, which is a positive 8. And you always want to tell what the first term is. So the first term is going to be negative 10. And we're done. Okay? So this is my explicit formula. This is my recursive formula. Let's try the next one, okay? So my first term's 117, 111, 105, 99. And I think quickly you can tell that the difference for this is going to be negative 6, right? Okay. So again, to get my explicit one, I have A of n, again, that means any term you want to find, okay, equals the difference is negative 6n. Now you'll notice I'm going down 6, so if I go the other way, my 0 term, and I add 6 to 117, I would get 123. So again, that is my 0 term. And now I have my explicit formula. Okay, again, the difference was negative 6. I go back 1 from my first term to get my 0 term. The recursive formula. Pretty simple again. You always start off with this. And you add two things. You add the difference, in this case is minus 6. And don't forget to tell us what the first term was, which was 117. Now I'm done with my recursive formula. All right. Let's look at a few examples here. We are going to find the 50th term in the sequence, all right? So, in order to do that, what I'm going to need is the formula, okay? And then I'm going to show you how the formula works to find the 50th term. Well, if you look at the sequence, we can see 43, 50, 57. We're going by plus 7, right? So we have 7. N, and again we're looking for what term? If that's the first term, we go back 1. So we're actually, instead of adding 7, we're subtracting 7. So my 0 term would be 36. All right. Now, here's how we use the formula. I'm not going to keep going and going plus 7, plus 7, plus 7 all the way to my 50th term. I'm going to use my formula, so I'll plug in this. This means, remember n meant number, so I'm trying to find the 50th number. So guess what goes in here? 50. Okay. And then 7 times 50 plus 36. Bust out those calculators, and the 50th term is going to be 386. Okay? Again, this formula is very useful to find a term way down the line. Okay? Let's look at my next one. All right? We are going down by 15. So my difference is negative 15. So let's get the formula first. So that's going to be negative 15n. Now you remember, instead of going down, we need the 0 term. So we're going to go up 15. So 60 plus 15 would be 75. All right, now let's use my formula. So I'm going to plug in 19 to my, so negative 15 times 19 plus 75. And then my 19th term in the sequence, well, it's going to go down. So even before I do the work, you assume we're going to get into negative territory, which we are. So my 19th term is going to be 210. All right, I'm going to stop it here, and then I'm going to do part 2 of this in a moment. All right, so stick with me, and we'll continue the notes.